In the video for topic 8.11, we're taking a look at a crappy topic, sewage treatment. For most of human history, the entire population remained relatively small and largely lived in rural environments. Along with the Industrial Revolution, however, came faster population growth, greater urbanization, and higher density living. The Industrial Revolution and the innovations that followed in the subsequent centuries have pushed civilization into the modern world. Electricity, automobiles, and advanced mobile technology changed the way we live. But it also brought air and water pollution, threatened the survival of a great number of other species, and the destruction of natural wild spaces. An especially unique side effect of our way of life is the generation of large volumes of wastewater, mostly within a relatively small area. Raw sewage carried away from our homes, schools, and businesses by plumbing systems must be dealt with properly before it can be released into the environment. Scientists who study the environmental effects of wastewater are concerned about it as a pollutant for three major reasons. First, the wastewater dumped into bodies of water is naturally broken down by bacteria, creating an increase in the oxygen demand by them. In conjunction with that, the second issue, the release of nutrients, fertilizing the water, causes an explosive growth of quickly reproducing organisms like algae. Eutrophication, sometimes called cultural eutrophication, is the result of anthropogenic inputs of nutrients like nitrogen and phosphorus. The resulting algal bloom is a short term, since the long-term effect is the decomposition of the algae once they die and a crash in oxygen availability in the water, creating dead zones. Only the circulation of the body of water can aerate the water and re-oxygenate it, which takes time. The third concern with wastewater is the pathogens it often carries. Disease-causing organisms are responsible for a number of diseases that can be contracted by humans or other organisms coming into contact with or drinking the contaminated water. Such pathogens cause things like cholera, hepatitis, diarrhea, and other gastrointestinal illnesses. Hepatitis is becoming increasingly common, even in industrialized nations like the US, due to inadequate sanitation practices, especially in restaurants. Cholera, more common in developing nations, claims thousands of lives annually. Since it should now be clear that wastewater must be dealt with in a special way to mitigate the potential harm caused by its contents, what is done to treat it? In rural areas, septic systems are the most commonly employed mechanisms to remediate the sewage. Homes essentially treat the wastewater generated within them using an underground system. A septic tank is a large container that receives wastewater from the house. A variety of capacities of these tanks are available to consumers based on the volume of waste that the home could produce. Buried near the home, the sewage flows out of the house, with gravity, and into the septic tank. Solids settle to the bottom, and over time, bacteria in the tank break down the wastes. The fairly clear water that forms over time, called septage, moves out of the septic tank, again with gravity, and into the leach field. Made of a combination of perforated pipes, the leach field allows water to seep out into the surrounding soil, where it can be remediated and filtered further by soil microbes. The water can then be carried off by groundwater flow, taken in by plants, or end up in surface bodies of water. Although household septic systems work well on a small scale, especially in rural, low-density areas, they are simply not feasible for urban or suburban environments. The higher population densities and lower availability of open land demand a different strategy. In developed nations, centralized sewage treatment plants are that strategy. In a traditional wastewater plant, the wastewater from homes, schools, and businesses is treated in a multi-step process before the clean water is released back into the environment. Although there are variations in design and techniques used to treat the wastewater, all modern sewage treatment plants rely on the same principles. Before any treatment of waste can begin, a filtration step exists as a pre-treatment of the water. This screening process prevents large objects from entering the plant's plumbing system that may damage it and the pumps that push water through it. Twigs and tree branches, disposable wipes, rocks, small stones and gravel, and plastic waste, along with anything you can imagine people flushing down drains at home, are blocked in this preliminary treatment. Other non-waste materials settle out in the grit chamber before the sewage to be treated continues on to primary treatment. The first step in the treatment process allows the waste to settle at the bottom of a large tank. The more dense, solid material is allowed to sink to the bottom of the tank, whereas oils and fats rise to the top due to their lower density, and are then skimmed off the top. Since settling tanks are usually equipped with mechanically driven scrapers, they continually drive the collected sludge toward a hopper in the base of the tank, where it is then pumped to sludge treatment facilities before being hauled away, often into a landfill. Secondary treatment, regardless of the specifics on how it is accomplished, always involves the employment of bacteria to break down the organic material in the wastewater. The bacterial population, fed by the constant input of sewage, grows in biomass and sinks to the bottom of the tank. Secondary treatment typically includes a method to aerate the water being treated. This adds oxygen to the water, promoting the growth of aerobic bacteria, which produce less offensive odors than the anaerobic bacteria do. The remaining water, mostly clear and nearly free of pollutants, moves on to the final stages of wastewater treatment. Disinfection of treated sewage may be attempted to kill pathogens before being released into the environment. The purpose of disinfection in the treatment of sewage is to substantially reduce the number of pathogens in the water before it is discharged back into the environment, or it can be reused. The effectiveness of disinfection depends on the quality of the water being treated, the type of disinfection being used, the disinfectant dosage or duration, and other environmental variables. For example, water with high turbidity will be treated less successfully since solid matter can shield organisms that are in the water. Generally, short contact times, low doses, and high flow rates of water all militate against the effective disinfection. Common methods of disinfection include ultraviolet radiation, ozone, chlorine, and sometimes even heat. The purpose of tertiary treatment, also called advanced treatment, is to provide a final treatment stage to further improve the effluent quality before it is discharged to the receiving body of water or reused. More than one tertiary treatment process may be used at any treatment plant. It is also sometimes referred to as effluent polishing. Tertiary treatment may include biological nutrient removal, disinfection and removal of micropollutants, such as environmental persistent pharmaceutical pollutants, and involves a variety of techniques. Reverse osmosis is a water purification process that uses a partially permeable membrane to separate ions, unwanted molecules, and larger particles from water. In reverse osmosis, an applied pressure is used to overcome osmotic pressure and can remove many types of dissolved and suspended chemicals, as well as biological ones, mainly bacteria, from water. Activated carbon, also called activated charcoal, is a form of carbon commonly used to filter contaminants from water and air, among many other uses. It is processed or activated to have small, low-volume pores that increase the surface area available for adsorption of minute particles or to provide a site for chemical reactions that remediate toxins. To see a video tour of a local wastewater treatment plant, click on the link above to check out the Sunnyside Wastewater Treatment Plant in Lake Stevens, Washington. Sewage treatment plants are critical to human health, particularly in densely populated areas. However, in developing nations, even those with large populations, dumping raw sewage into waterways is a common occurrence. But it might be surprising to know that even in the most developed countries, raw sewage can sometimes be directly pumped or released into rivers and lakes. Sewage treatment plants are built to handle the wastewater from local households, businesses, and industries. However, many treatment plants, especially older ones, also receive water from stormwater drainage systems. During periods of heavy rain, the combined volume of rainwater and wastewater exceeds the capacity of the treatment plant. When this happens, the treatment plants are legally allowed to bypass their normal treatment processes and release the storm and wastewater back into the environment. With that, topic 8.11 has come to a close. Thank you and take care.